Hello and welcome. My name is Ed Niedermeyer. I'm the Communications Director here at Partners for Automated Vehicle Education, and I'm extremely pleased today to welcome another new member to PAVE's Educational Coalition. The newest member here at PAVE is LHP Engineering Solutions, and with us today to talk about LHP and the work that they do and how it applies to the work that we do here at PAVE. I'm joined by CTO Steve Neemeh. Steve, welcome.
Oh, thanks. It's a pleasure to be here, Ed. Thanks.
So start by telling us a little about yourself and the work that you do at LHP.
Sure. So I'm the CTO of LHP. My background is in embedded software, and I've worked, I started my career in automotive, but I've moved to aerospace and defense and then kind of rolled back in to lead the safety aspects of the LHP business, which, LHP is a services and technology integrator, and effectively consulting in the space of software development almost all over the map on automotive. And then, about 5-6 years ago, we, built a vertical in the safety aspects of it and like product development in the safety space for safety critical systems. And if you think about automotive these days, it's becoming the fact almost, all aspects of automotive is becoming safety critical. So we're very busy these days doing those kinds of things.
Absolutely, and a huge amount of what we get asked about here at PAVE when we get questions from the public is about safety and what it means and how you understand it, and so I think let's dig into that a little bit and get some of your insights. So when you talk about safety work in automotive, as you say, obviously, like cars, there's tens of thousands just in this country of deaths every year associated with cars. So people understand that safety is really important to that, but people don't often understand like how do you do safety work as you're developing a car? What does that even mean? And so let's start with that in sort of the traditional automotive context. What is this work that you do sort of in more nuts and bolts terms?
Historically, all organizations have somewhat of a safety organization already, right? So when there's an issue on the road somewhere, there's always a safety person that takes a look at the issues that come up. And there have been many public ones, but actually there are many, many more non-public ones. And I think what's happening recently is, the automotive landscape is becoming software, and software is something you can change on a dime. I could change it from my desk right now and download it onto your vehicle. And it just brings an entirely new landscape of how you have to handle that. So about 10 years ago or so, the first safety critical standard specifically targeted to automotive came out, and it was foundational, from IEC 61508, which is a very old safety standard, but targeted towards automotive, which was 26262, and what people generally call functional safety. And it laid out guidelines for people, and across the automotive span, whether it's a tier or OEMs, at this point, 10 years later, everyone's touching it a little bit. Now. When it comes to really safety critical items, if you think of things like nuclear and medical devices and insulin pumps, and now autonomous level 5 vehicles, there's an added layer, which is, infrastructure and government, which is somewhat involved, but I think is going to evolve quite a bit in the next few years.
Yeah. Well, and so, I think it's really easy to think that, sort of everything to do with safety sort of comes down to like a government standard, for example, a law that, things need to be this. And the obvious example of this is, of course, crash testing or whatever. And there are crash tests, but there's so much more to safety and to understanding safety and to engineering safety into a vehicle or really anything. And so you mentioned standards. ISO 26262 is one that some may be familiar with, but walk us through what does it mean to go through that process of showing that the vehicle that you're developing or the subsystem or whatever it is complies with that standard. What does that mean?
Sure. In general, right now on the government side of the world, NHTSA kind of does reviews of certain things to make sure that they work properly for the public, right? Generally, that's after the fact, right? It's after the vehicle's built, and then they run through a battery of tests. Now, what functional safety says is that throughout your development process, you're going to not only guide the engineers, but restrict them, and then ensure that your process doesn't allow human error. So if you go from the top, there's a very public, accelerator pedal taken off on you, right? That's very common, very public one that came out. Well, it says that you're going to put a goal, organizational goal, that's never going to happen. and then from there, requirements will be developed and engineers will design to those requirements. And then those requirements will be tested. And then by perhaps an independent person so that they're unbiased. And then there's a quality organization which will make sure those steps happen before the vehicle actually goes to production. And then there's a culture in the organization that if it doesn't happen, we're going to hit the brakes and we're not going to ship this product. So if you put all those pieces in place, that's, in a very quick 700-page document described in 2 minutes. That's what ISO 26262 wants. Now there's a whole other layer now, which once you've got this nice framework in place, how do you do it in a scenario which is infinite test cases like autonomous driving? You can follow that process if you can clearly define, the use case at the front end. But if you can't define that, or if it's infinite, right? There's millions of cases, the kid runs across the road, dog, tree, lights are out, just infinite test cases, then it becomes more complex. However, foundationally, if you don't have that first piece, then whatever you do is subject to human error because you're not controlling it within your organization.
Right. So that's fascinating because that first step that you identified is it's sort of anticipating what are the possible things that could go wrong, essentially, right? It's what happens if you misapply the brake or your steering fails or something. Like this is hazard and risk analysis, right? Right.
It's hazard and risk analysis, and then it's called a hazard analysis and risk assessment.
And
you lay that out, and you lay that out one by one and define safety goals and take those down to requirements in a very deterministic way. It's when it becomes non-deterministic that it becomes much, much more complex.
Right, and exactly, and so I think it's an easy way to start to understand that with a car, that doesn't drive itself, that's just a typical car, the things that can go wrong, all exist within the vehicle itself, right? And then when you
get into, sorry, I cut you off.
Yeah, no, and then when you starting to get into automated driving, then all of a sudden that the hazards and risks are almost as much about what's going on around you, right, as in the vehicle itself. What does that mean for sort of functional safety and safety assessment?
Yeah, so that's a good question, actually. And I think when you think about the safety of the vehicle, at the end of the day, when you're designing it, and you want to achieve the safety goal, you're going to come up with a mechanism, right? So that unintended acceleration or other fault doesn't happen. But it oftentimes in today's world, it defaults to the driver, right? And so now we're saying we're not going to default to the driver. So there's a bunch of recalls out there that I actually looked into, a minivan with the sliding door that opens on the highway. You still default to the driver, oh, I'm going to pull over. Well, all those things have to be factored in. Now let's take the outside world. Now, all of a sudden, it's not just the OEM anymore, right? It's the traffic conditions, communication with the infrastructure, potentially, construction, all these things. And what that means is you need a new hazard analysis and risk assessment. But unfortunately, that one's far more complex. And you might have to stage it very slowly from I keep thinking about how do I make an autonomous vehicle safe? Well, I might have to go road by road. I might have to map the world. I might have, and by the way, all those things are happening. People are mapping the world, and Google Maps already maps the world, right? So, but a whole other level of that is occurring. A whole other level of GPS accuracy is occurring. But then going back to the vehicle, even if you're smart enough to navigate all that, the vehicle better stop when you say stop.
Right.
Because and just those basic things,
because you don't have that human there as backup. And I think that was something that opened my eyes when I first learned about functional safety is, if your power steering goes out, you still have some ability to control the wheel. It may not be as easy. And ultimately you, the human, when that functional safety analysis is happening, you're that backup, right? You're there to take over. And so and I think this kind of ties into a lot of times people think that there's this simple transition from level 2 automation to level 3, because in level 2, right, if something goes wrong with the automation, the human is there, but you have to be. That's the way those systems work. But when you get into level 3 and above, then all of a sudden you can't just rely on a human being there to back up and talk about sort of how much does that sort of explode the problem space that you're working with? Give us a sense of the scale of how big that jump is.
So my opinion is we've already hit a brick wall. because when I open up my user manual for my vehicle, which has ADAS in it, it specifically says forward collision, which is tested by NHTSA, by the way, is not going to avoid all collisions, and it's your problem. So long as it says that, and so long as the manufacturers don't own the responsibility, we can't move to the next step, right? And then historically, by the way, like go back to the 1900s, American History Museum, you can read about, initially the driver was the primary focus for safety. And then the manufacturers started stepping in. There was advocacy, and here we are again, by the way, there was advocacy for education on seatbelts and things and drunk driving and training. All those things started coming in. And even manufacturers got involved with, how to design the dashboard so that when there is an accident, it's a smooth dashboard, and all kinds of little things like that started happening. And we're back to that same point. These wonderful features are coming out and everyone wants them, right? Because they're exciting. And then, I think what'll happen is some issues, and unfortunate maybe carnage, which already has happened, by the way. It's just somehow, not, well, first of all, there's not that many autonomous vehicles out there or even autopilots. I mean, there's very few, very, very few. And we have very, documented examples of issues. So we've hit a brick wall, I think, and it'll have to change when the manufacturers are comfortable taking that responsibility, because that is going to be theirs, in the end. And it'll be an argument between them and the drivers, and I think eventually the government.
Yeah, and sort of on a technical or like on a systems level, sort of what is needed to get to that point where you're not just sort of, well, if something goes wrong, ultimately it's just the driver's responsibility.
Yeah, so I think from a design standpoint, those functional safety standards, they give you statistics that you've got to compute, and then a failure on the vehicle shall not occur more than, 0.00801 times per million, and so on and so forth. And when you design and follow the steps of functional safety, the vehicle will be designed that. And so the likelihood of anything occurring is extremely low. The manufacturer has shown all the steps they need to, burden of proof that they've done what they should be doing so that it's safe. Now layer on top of that, autonomous driving, which is non-deterministic, and you're going to have a risk-based approach. It's risk-based. How risky is it? And I think that'll be a combination of like simulation right there in a lab, and then perhaps attach, lab-based environment and real hardware in the lab before it goes out. And then the vehicle itself, after it gets released, will likely have a continuous improvement or monitoring type system. That combination, I think, will lead to a risk value. And I know that hasn't evolved as a number. I think that's how it's going to evolve, some kind of risk probability that you're comfortable with, and we go out with that. And then over time, that becomes, 85%, 95%. I'm 0.0000001% probability of failure, and I think that's how it evolves. But I think at some point there has to be some initiative that forces that to happen, because I don't think just independently people will do that. So that event could be governmental or it could be accidents, either way,
Yeah, no, it's fascinating. And what about standards? I mean, you mentioned 26262. We have, and again, it's I think people don't always appreciate how much these standards really do to ensure the really quite high safety level that goes into cars these days. But as you mentioned, moving into that sort of probabilistic design space, like there are some challenges there. What do standards need to do to kind of catch up to that? Is that happening? Is it sort of early days of that? Help us understand what's going on with that.
So the ISO 262 committee spun out a standard called SOTIF, safety of the intended functionality, attempting to address autonomous driving. But these standards are guidelines, right? They're guidelines, and this specific one tells you that you're going to measure over time your unknown risk. So there's known risk, like things that could happen, and you cover for those. But there's unknown risk, and over time you're going to reduce the unknown risk. And that's all. It says a lot more than that, but it doesn't tell you how to do that. So who gets creative enough to lower their unknown risk? And I'm thinking of like this, very sophisticated vehicle, which is constantly monitoring its environment. It's constantly feeding back information to the office. The engineers are constantly going through any potential errors or hazards that might have occurred in an environment they didn't predict. And that gets improved over time. So SOTIF is one of them. There's other standard from UL that came out. And so everyone's putting out these standards. Now, if you have a standard, the real question is enforcement. Who's enforcing it? Right now, it's voluntary all the way around. And some companies are taking the extra step of hiring our partner TUV Nord, for example, or other TUVs, especially in Europe, to come in and review that, specifically on the 26262 case, so that at least foundationally your product is safe or good for safety applications. But enforcement is a big issue. So you can implement something and then not enforce it. It doesn't really end up with a safer product at the end.
Yeah, and we have seen again sort of voluntary safety self-assessments from sort of NHTSA's guidance. But then what's been interesting is to see some of the companies starting to put out more of their safety case framework, put out more even of their safety data than regulators are required to. In some ways, it seems like this is because this industry is it's as much about competing for trust as being sort of first to market. Sort of how does would you agree with that view, and sort of how does that play into the work that you're doing?
Well, there's a lot of organizations that are creating, standards, standards by which people can communicate, right? How do you develop a standard for scenarios, right? Like I mentioned earlier, dog, cat, and grandma, whatever scenarios you want. And so there's common frameworks being developed for that. There's common frameworks for sharing of data. And I think people have, in the end, they know there's no way one organization or one company is going to solve this problem. So there are going to have to be multiple things that occur, and standardization across the board is going to have to happen in some way, shape, or form. There's already, one thing we focus on is AutoSAR. AutoSAR is a software standard. But if everyone develops software the same way, then they can all talk the same way, then they can all test the same way, then we can automate. And the second you can automate things out, then it gets better. So those kinds of standards, they need to be developed, and they are in process of development for a lot of pieces, but no holistic solution has come out and no mandate has come out either.
Yeah, and so sort of in this environment where, as you say, there's not really much enforcement, it is really just about, do you want to earn the trust, right? Because people ultimately are going to have to trust their lives to this technology. It kind of brings us back to something that you actually mentioned earlier, which is, again, I think something people don't necessarily associate with these standards, but that's culture. That the culture of how you approach safety in the work that you do in the space is really important. Can you help people understand why is that important? Because a lot of times people hear culture and they think, oh, this is just kind of PR talk or whatever, right? So help us understand why, in sort of more material terms, culture is so important in this work.
Right. So I've worked in a couple of startups in the non-safety critical space, power gen space. And the example I can give you is I used to release code daily, right? So daily there'd be a problem in the field. I'd release code. I'd fix 10 problems and I'd create 2. And then the next day I would do exactly the same thing. And I'd fix 2 problems and I'd create 5. And it was an endless cycle of, we need to ship the product and this is what we're going to do to fix it. Steve, get on the line and start fixing it, right? So, and that was a very stressful environment. Now, and I moved to safety critical applications, right? So navigations or flight controls. If there's a problem in the field, the person who's responsible for it, the safety director or whatever you want to call him, trumps the CEO. He has the responsibility. So culturally within that organization, the safety person is one of the strongest people in the organization. He can stop shipments if he doesn't believe that it's safe enough. And so that's true for, this is why that 737 MAX issue has drug on so long. This is why some of these other things take months and years to solve, is because although the engineers have an idea of how to solve it, at the end of the day, they're going to have to prove that to their internal organization, their quality organization, their safety director, the FAA, whoever it is, before it ever sees a consumer. And that's a big difference between, what a startup company's culture would be, which is get the technology out and innovate, versus make it safe. So the culture actually matters a lot. It matters a lot.
Yeah, no, that's really helpful, because I think, again, it's so easy to just kind of have this fixed sense of how startups work and how new technology companies work. And really this is, this is kind of a unique area of safety critical technology, right? Because it's systems making decisions in ways that are safety critical in life and death, in ways that we haven't really seen that much before, right?
Right. And I remember, in certain organizations, actually, they put out a video for you for you to understand where your product is going, right? And in some cases, it was in soldiers' hands. In some cases, there was passengers, and they sort of give you a little bit of a, scare. There's a fear factor in showing you all that so that you know that your job is not like a cell phone, right? Which worst case, it might heat up your pocket. It's actually somebody's life, and you don't want to be responsible for that. You really don't want to be responsible for that. As a human being, you don't want to be responsible for that. So
absolutely. And so sort of coming out of the safety culture, the importance of culture in this work, why is the work that PAVE do important enough that you would join our coalition? How does the public education piece fit into all this safety culture and safety engineering work?
So I had a couple of interns working this summer testing ADAS features, and they didn't realize, for example, that adaptive cruise control could be turned off. So, cruise control generally, you just set a speed, right? But adaptive cruise control keeps you away from the car in front of you. Well, they didn't realize that you could have options there. So they set it, started to video the situation, and they were approaching a car and slammed the brakes. I mean, so we're talking about like 20-year-olds, right? They should be up to speed on the technology. However, they weren't, and they were clueless about it. Not only that, but I think, the automotive companies are currently selling these ADAS features as safety features, but they're not really safety features. They're luxury upgrades, like that's what they are. So we need to educate the public, I think, in one sense. And then there are very, fundamental ways that we could go into organizations as auditors or as consultants to actually help set the structure. And we've done that for organizations. So education at the governmental level, I think 2015, their functional safety made it into a bill. And I think so somebody's saying something. And I think the more people kind of understand that concept, the better, because there are ways to make sure that the carnage does not happen. So education at the public level from a usage standpoint is really important. My daughter just finished her driver's ed course, and I've educated her on the usage of all of this stuff, even the camera, which she assumes is foolproof. It's not foolproof. You cannot see the same wide angle. It's not the same. So it's interesting how that part has to happen. And we mentioned trust, right? So at the end of the day, if you want to sell an autonomous vehicle, there has to be an enormous amount of trust. And now, after you've done all that, imagine we haven't even talked about the cyber aspects of it, for example. So trust comes in not only with functional safety. Functional safety can't happen if it's not cyber secure also.
Yeah, absolutely. And ultimately, the public can't know if a company has really earned their trust unless they have some basic understanding of all this, right?
Right. And I mean, NHTSA already has this 5-star rating when you look at the cars, right? There's a 5-star rating, and they tell you we've tested these things. Eventually, be a 5-star rating and safety certificate, risk profile. I don't know the word that's going to be used, and I don't even know that it's NHTSA. I don't know. That's what's evolving. But I'm going to be looking for that. This is a car with autonomous driving, and here are the risk categories, just the same as we had, there was once a time when we were at the beginning of crash safety where everyone was always looking for that, right? What's the safest car for my kid to be in? And I don't know that we look at it as much anymore because everyone's got the airbags now and everyone's got the crumple zones. I'll be looking for that for the autonomous car. I mean, I kind of want it. I want the autonomous vehicle for many reasons, but I'll be looking for the risk. What risk identification and risk profile does this car have? And am I comfortable with that?
Absolutely. And I think you will be far from the only one. And I think in particular, the expertise that you have in sort of understanding safety, some of the things we were just talking about, are going to be really important to help people understand that, so that they can be looking for this stuff as well. I think oftentimes it's easy to think that things are sort of happening in a vacuum, but really all of this is sort of a big public conversation, right, with the public, and they need to be able to speak the same language in order to have that conversation be one that really builds trust, right? Right.
That's right. And I think to give the organizations in the automotive industry credit, they're down the right path. The problem with all these things, obviously, there's a humongous cost and time implication to doing the things I mentioned earlier. And, so that's why automation, tool integration, and things like that would accelerate the labor aspect of it and remove human error and automate as much as humanly possible out of the process is really key. And then I think you can put your name on it and be comfortable with that. And the public will then be comfortable with that. But when a car runs straight into a semi on a highway, which is actually a very simple case, right? It's a big thing in the road on a freeway on a straight line, and you just see that thing running. It's like that something's off. Then people will lose trust. And if 5 or 6 of those things happen, you lose a tremendous. It's over. It's over. You just roll that whole thing back. Roll it all back and go back to driving. So.
Absolutely. Well, hopefully with your help, we'll be able to make some impact on that public education piece of the challenge, because you're absolutely right. There's so much misunderstanding out there. And we really appreciate folks like you and organizations like LHP joining us, supporting us, and really bringing the expertise with all of the things that you've described here today. It's fascinating stuff. I really look forward to talking about it with you some more in the future. Steve, Neemeh, thank you so much for joining PAVE and for taking the time here to talk with us today.
It's my pleasure, Ed. I'm really excited to be part of this, to be honest.
Us too.